we'll be understanding the concept of mesh analysis, what essentially is a mesh analysis, and what is a super mesh, and other factors. So we'll be just seeing, okay, how do we go about the mesh analysis, the concept of the super mesh, and other factors. So let's go around it. So let's understand what exactly is a mesh. So today's topic essentially will be understanding mesh and super mesh. Before moving to the mesh and the super mesh concept, let's analyze what is a mesh. So if you see a circuit like this, we have a circuit x1. This is an element, okay, x2, okay. One more element I have x3 over here, and this is x4, x5, and let's suppose this is x6. So this is x6. So in order to understand what exactly a mesh is or a loop is, so first of all, before moving to the mesh, so there's a difference between a loop and a mesh. So what is a loop and what is a mesh? So basically, if you say a loop is a closed path such that no node is traversed more than once. So you can see here a loop is a closed path if we write the A, B, C, D. Okay. So here this is the reference node E as in our nodal analysis lecture. So what we see is that a loop is a closed path wherein no node is traversed. A loop is a closed path wherein a node is we can say is not traversed or traversed more than once. So what does that mean? That means is, suppose this is our loop over here, you can see, so is a closed path wherein see A and B, okay. In this, if you see A and B, all the nodes are traversed only once. Similarly here, B and C is traversed only once. So C and D is traversed only once. So you can say this network is having how many loops? So it can be said that this network is having at least three loops. So those loops are loop number one, loop number two, and loop number three. So over here we can say that loop is having a three loops. So what is a mesh? Basically, a mesh is a loop that contains no other loop. So mesh is a loop that contains no other loop. So mesh is a loop that contains, this is the difference, contains no other loop. In other words, you can say that your mesh is a loop, but your loop is not a mesh. So how we can say that? If we see this network, we can say that how many loops we are having, for example, and how many meshes we are having. So in order to understand this, so if we see x1, x2, x3, there was one loop, okay, then a loop is a closed path such that no node is traversed more than once. So if we, are there only these three loops, or there are more than these three loops? Not the node is not traversed more than once. So let's assume x1, x2, x3, okay. This can be a loop x1, x2, x4, okay, and x5. This is a bigger loop. See here, I'll draw with the different color here. This can be a loop, okay. Now, okay, similarly you here you can see A, B, C, okay, and E. So a node is not traversed more than once, okay. That means it is not coming A, B, C, then B is again coming. So it's like that. So we have to understand, so how many loops it can have. So if we carefully see to it, so we can carefully write that it is having how many loops. By now you should have understood it is having six loops. And what are those loops? Those loops are uh, x1, x2, and x3. That is x1, x2, and x3. The second loop that I drawn, I can now take with x3 also. See, x3, x4 and x5, these are the basics. x3, x4 and x5. Okay, then with x5 and x6 you can write, these are the basics elementary which you can find out, x5 and x6. Now comes to the little part that you have to see through it. Okay, so why I am showing you all this, because sometimes a KVL equation na, we have to operate, so we have to operate it through the bigger loops also. So the bigger loops, as you can see here, you can see x1, x2, x4 and x5. So this is the bigger loop, x1, x2, x4 and x5. So this can be one loop. Now can you write x1, x2, x4 and x5? So similarly, by now you must have understood what else you can write. Can't you write x1, x2, x4 instead of x5? We'll go like this. So I'll draw it with a different color. We can write it x1, okay, x2, x4. Instead of x5, we'll go through x6 and the path is closed. Suppose it's a voltmeter, this plus sign, this negative sign. So I'm connecting x1, x2, x4. Instead of going x6, I'll x5, I can write this. So I have x4 and x6. So these are the essentially the loops that you have seen. So is there any other loop apart from that, x1, x2, x4? So you can see with respect to x3 also, x3, x4, x5 we saw, x3, x3, x4, x5. Can't we write x3, uh, x3 with yellow color I'm drawing, x3, x4 and x6. So this can be one more, x3, x4 and x6. So it is having essentially six loops. Okay, so these are the loop. This was the concept of a loop and a mesh. Now let's go to the mesh analysis concept directly. Let's see how the mesh analysis, how we have to analyze the mesh analysis concept. So as far as the mesh analysis concept is concerned, so what is a mesh analysis concept and how do we go about it, you'll be understanding. So the steps in order to understand the mesh analysis, or we some books also use it as a loop method. So we'll so steps to analyze mesh analysis, mesh. So steps, there are some essential steps that you have to keep into mind. The step number one over there would be to select a set of meshes such that at least one mesh passes through each branch. So you have to select a set of meshes, okay, that at least one mesh passes through each branch, through each branch. So this is the step number one. So that would mean you have to, like in the nodal analysis case, you have labeled. So again here, label each mesh with the corresponding mesh current. So you have to label each mesh with corresponding mesh current, with corresponding mesh current. So this is important. You have to label each mesh with the corresponding mesh current. And then what you have to do is that, and assign each mesh current an arbitrary direction. And see, I will use and assign each mesh an arbitrary direction. Okay, arbitrary. So it is up to you, arbitrary direction, what direction you are applying. But if you have not seen my video, basically the mistake is here. So you follow the passive sign convention. Okay, passive sign convention would mean if it is a voltage rise, usually if it is plus minus like this, and the current is moving in this direction. Okay, so that is what basically, or this, if this is plus minus and the current is moving like this, so this is basically voltage rise. Okay, and if it is plus minus and the current is falling, so this is voltage fall. So you have to, like, you just concentrate on voltage rise is equal to, okay, voltage rise is equal to voltage fall, or I'll or sum of voltage rise is equal to 0, or voltage fall, sum of, that is sum of voltage fall, all the voltage fall at a one particular point would be 0. So so this is for your understanding. Okay, then in the mesh analysis, what you do is, unlike the nodal analysis where you initially apply KCL and then write the current equation in terms of voltage and resistance by applying the Ohm's law. Here what you do is, instead of applying KCL first, you have to apply KVL. Okay, so apply KVL around each label, around each labeled mesh. So around each labeled mesh, so you have to just label the mesh, and around with each branch voltage expected in terms of, and each branch voltage, again you like branch voltage, you can replace again each branch voltage is written in form of branch current and resistance, branch current and resistance, whatever branch voltage is expressed in terms of, okay, branch current or the mesh current via Ohm's law. So Ohm's law means IR, Ohm's law. So one more important concept here is that be sure to relate current directions with voltage polarity according to passive sign convention. So here this is the important point where most of the students are missing it. Please pay attention. Be sure, I'll write be sure, okay, to to relate, okay, to relate current direction, to relate current direction and voltage polarities according to passive sign voltage polarities according to passive sign convention. So this is very important point over here. So this is the second most important point. When we'll be doing a problem, I'll be applying these steps, and if you are having any doubts, you can put in the comment section. You can ask me. Okay, so solve the resulting set of simultaneous equations for the, that's it. The third step is the solve the resulting solve the resulting set of simultaneous equations, and you will get the answers. Simultaneous equations for the unknown mesh current, for the unknown mesh currents. So basically you notice in the nodal technique we were calculating the voltage, here we are calculating the current. Now suppose I'll take an example. Okay, so let me take an example of a circuit over here. So I'm drawing a circuit. This is my plus minus 13 volts. I have a resistance here, one more resistance over here. So this is my resistance, one more resistance over here, one more resistance over here. I have a voltage, another voltage source over here, and I close the circuit over here. So this is I'll keep a value of 13 volts. Let this be 13 volts. Let this be 3 ohms. Okay, let this be 1 ohm. Okay, let this be, basically what happens is that when you are calculating, so remember voltage would be in volts, current would be in milliamps, and usually resistance would be in kilo ohms. So this is the standard technique. So voltage in volts, okay, current in milliamps, and the resistance would be in kilo ohms. So this is the standard practice whenever you are doing the problem. So please keep in mind these are the essential things. So here we will we this is for the other thing. So here we will be just solving. Let's see. Okay, this is 3, this is 1 ohm. Okay, so this is 4, and the other thing is that this is 2 volts. So this is 2. Okay, so we have to calculate the branch current. First of all, we have to assign a branch current. Suppose we are assigning the direction of the branch current. So the branch current direction should be, if we are going for anti-clockwise, so this is the clockwise direction. So usually we go for the anti-clockwise. If you are going for clockwise, you can go for clockwise. If you are going anti-clock, then follow the anti-clock. So any which ways you can go. If you are following this clockwise, you can go clockwise also, no problem. So here I have taken the current, okay, like this. Here I have taken the current like this, okay. So this is my I1, this is my I2. So this is my I1, this is my I2. Now I know that there is one loop over here, another loop over here. So in this loop my voltage rise. See, I have told you the passive sign connect plus and minus, so this is the rise, so I'll take it as positive. So this is 13 volts. So rest the elements connected here are resistance, it's bulbs. So this would be always fall. So voltage rise is equal to voltage fall. So from here I can write my equations. 13 is equal to 3 I1 plus 4. Now the current over here, the current over here. Suppose if I am showing this direction as I1 is going here, okay, and I2 is leaving this side, I2 is leaving this side. So if this is a node at this point, B point, so let's write A, B, C. So B point. So I1 is entering B, okay, and what is leaving B? Suppose this is my X. So X is leaving. What else is leaving? B, huh? I2 is also leaving B. So I can write I1 is equal to X plus I2. Or in other terms, if I want the value of X, X would be I1 minus I2. So the current over here is I1 minus I2. That is my X current. So I can write in terms of 4 into I1 minus I2. So this can be written as 4 into I1 minus I2 over here. So this is voltage rise is equal to voltage fall. No problem you should have. Okay, this is one equation 1. So what we did is that, if you just notice here, select a set of meshes. So we selected a set of mesh. So this is A, B, C. First we have to label A, B, C. This is D point, D point, D point. So we have A, B, D. Okay, so one mesh is our ABD, okay, another mesh is our BCD. So we have selected on two meshes over there. But if you closely monitor here, how many loops are there? So there are only two meshes, but as far as the loop is concerned, so how many loops are there? A, B, D was one. We can write another A, B, C, D is also one, okay, and that's it. We have A, B, D, okay, B, C, D, and one more loop. If we have to write a bigger one, this is this, okay, this is this one. So that's it in this situation. But our these two loops will, so now we let's move to the second point over here. So we are seeing there is resistance, and here the current direction is like this. So this is fall. So across this resistance there would be fall, across this resistance also fall. So sum of faults would be equal to 0. So the fall sums, all the sum of faults would be equal to 0. So here we have 4 into this. C, the direction of current. See, now we want it x, okay. So I1 was like flowing like this, okay. So here as far as if you are seeing over here, now you will say, sir, when you saw this circuit with respect to this, you wrote I1 minus I2, but when you are seeing with respect to this, you will change. But because with respect to this we had taken anti-clockwise direction, here we are taken clockwise direction. So we have to write it 4. Instead of I1 minus I2, it would be I2 minus I1. That is 1 point. This is a fall. Second, across 1 ohm resistance, you have straight away I2. Okay, that is 1 into I2. That is your, because this is 1 ohm. And then you have the voltage fall again 2 volts. So you have equation 1 and equation 2. From these two equations, you can get the value of I1 and I2. It is very simple. If you remodify the equations, you will get 7 I1 minus 4 I2 is equal to 13. Similarly, you will get the other equation would be equal to 4I1 minus 5I2 is equal to 2, wherein you can easily calculate I1 is equal to 3 amps and I2 is equal to 2 amps. Now, let's take a slightly bigger problem, and I want you people to do it for yourself. So, let's take another problem, okay, and let's understand it. See, let's suppose I have taken another problem wherein I take a voltage source over here. This is 1 volt plus minus, okay. So I have a 2 kilo ohm resistor over here. This is 2 kilo ohm or 2 kilo ohm resistor. So again, then I have a 10 kilo ohm resistor, 10 kilo ohm resistor. Then here I have my 6 kilo ohm resistor. I have one more 4 kilo ohm. I have one more voltage source, 7 volt. I have one more resistance. So I have taken this as 4 kilo ohms, this as 8 kilo ohms, and now one more voltage source. Uh, one more voltage source I have here. This is my plus minus 15 volt, and this is my 1 kilo ohm. So I'll be rubbing this here also. Okay, so we'll understand. Okay, so this is my circuit, how it looks like. This is my 2 kilo ohm resistance, 4 kilo ohm, 8 kilo ohm, 15 volts, and this is here around 1 kilo ohm again. Now first step would be to label it. Okay, to label. So this is node A. Okay, till here it is A, then it becomes B over here. Here it becomes C. Okay, then it is D here, then again it is becoming E. Here let's say it is F. Okay, so till here it is F, and till here it is D, because same no, till here D and till here F, because there is no element in between. So first we have labeled. Now let's see, if you clearly see, there are three loops. We can see 1, 2 and 3, clearly three loops. As far as the meshes are concerned, there are many meshes. This is A, B, C, D. Here also you see A, B, C, D, F also is a mesh. Okay, because it's a closed path. A, B, C, D till here. Okay, it's a closed path. So F, because see, this is the positive element that is getting connected, and you are connecting other elements over here, and then finally, so now you can do it with the three things. So let's take the current here I1. Okay, let's take the current here as I2. Okay, and let's take the current here as I3. So we'll take the current. So as far as the first mesh is concerned, this is the rise of potential. So minus to plus. So this is V rise. So we'll write 1. Rest across this 2 ohm, you'll see there is a fall. So this is 2 into I1. Here again it would be plus 6 into I1 minus I2, like in the last problem you saw. Just look at 6 into I1 minus I2. Then now this is for this first loop, and then you have this plus 10. So this current here I1 is shared with I3. So here this mesh, there is I1 and I3. So it will be 10 into I1 minus I3. So I1 minus I3. Now, as far as the second source is concerned, here you see this is also fall resistor. This is also fall. Now the current is also fall. You see voltage. This is, if the direction of the current was other way around. So 7 volt, we would have written voltage rise is equal to voltage fall. But this is completely a falling circuit. So we'll write 0 over here. Okay. The first value would be 6 into I2 minus I1. That would be I2 minus I1, and the second value over here is 4 into I2 plus 4 into I2, and the third value over there is 7 volts plus 7 volts, and finally 8 I2 minus I3 plus 8 I2 minus I3, I2 minus I3. Similarly, if you see this, the last source, so the direction of I3 is taken like this. So you can see the direction is like this of I3. So it is, I will repeat, minus to plus. If the direction of current is like this, so this is voltage rise, and this would be positive. So no need to confuse. So we have a term for voltage rise. So our one voltage rise is equal to 15 volts. So rest all the terms are resistor and all that. Across the resistor there won't be any voltage rise, because resistor is an energy absorbing element. It does not deliver an energy, wherein this is the battery source, which is an energy delivering element, and you have to take the passive sign convention. So that is, you have, wherein the mistake students are making. This is 15 volts. Okay, then this 15 volt, rest all again you will write 15. First terminal is 10. So this is I3. So first I3 comes, I3 minus I1. So this is that branch. Okay, then here 8k, that would be plus 8 I3 minus I2. Okay, and now similarly the last thing here is I3, so 1 into I3, 1 into I3. So if you solve these three equations, you will get the values of I1, I2 and I3. So this is very simple. You use Cramer's rule, or you can use calculator, whatever technique. Okay, there's 1 milliampere, and here this is 1 milliampere, and I3 is equal to 2 milliamps. Now let's understand the principle of super mesh. So what happens is that, what is a super mesh? So that is the thing that is important. What is a super mesh? Is a super mesh, so we saw in case of an super node, if there is a voltage source between two labeled nodes, this is that was called as a super mesh. Okay, if there was a voltage source, there is A and B. If there is resistance and a voltage source, that is not a super mesh, only a voltage source. Similarly, if there is a current source between two labeled meshes, that is called as a super mesh. And a case requiring special treatment occurs when two or more unknown mesh current pass through the same current source. So we'll write case uh, a case requiring special special treatment arises when two or more unknown mesh currents pass through the same current source. So what we do is that, so this difficulty how to overcome is that, what we will do is to bypass this. uh, See, what we will do to bypass this, to bypass this okay, what is done to bypass this? The meshes, the remaining meshes that have connected with this current source, the remaining meshes, okay, will have to be expanded to larger mesh called as super mesh. So we will then what we do is that, once the loops would actually be, see what we do is that, after we apply it, form it into a super mesh, then we apply KVL, and then these the super mesh and the mesh has some constraints that will be explained with the one simple problem and one difficult problem, so it will be very easy to understand what exactly I meant. So here you consider one problem. So this is a 12-volt source over here, plus minus, this is 12-volt. So let's suppose this is 1 ohm. This is very simple, elementary. Okay, this is 4 amps. Okay, here. So now, okay, there is one 3 ohm, 3 ohm, and this is 1 ohm. Okay, now you see over here, if I label it, this is my A point, this is my B point, till here also B point, this is my C. So what happens is, this is a label node A. Okay, uh, this is a label node, again the same node B. So what happens, a case requiring special treatment arises when two or more unknown mesh currents. See, this is one mesh current I1. Okay, this is I2. Okay, so what happens is that this is also passing through this. This is also unknown mesh currents pass through the same current source. To bypass this, the remaining meshes will have to be expanded to larger called as super node. So you see, between these two or more meshes, what happens is that we have a labeled. Basically, we have what? We have a labeled this thing. current source. So this is called as a super mesh. Okay. So a case when two or more unknown mesh pass through the same current source, you can see this. So this difficulty is overcome by alert by altering the choice of mesh current, so that only when one mesh current can pass through the offending current source. So here what I will do is that, see, I can from here I can write my KVL equation. So here it is given I1. If I take my I1 is equal to same as 4 amps, okay, that we can do over here. And I can write my 12 is equal to, again, 12 is equal to 1, okay, into I1 plus I2 plus 3 I2. So what I can do is that, see, basically, first case and second case, see, first case is my simple case, first loop is this, and the second loop is my super mesh. So in order to explain the super mesh, so this would be my first mesh, and this is my super mesh. So the red one is my super mesh. So in order to understand this, what I do is that, since the circuit is containing two meshes, so what I do is that, sharing the same current source, so we let only the first mesh pass through this source. So when we are letting the first mesh pass through this source, so we will expand the second mesh. So when we are letting the first mesh to pass through this source, only first mesh, so we can directly write our I1 is equal to 4 amps. So only this case, so I1 is equal to 4 amps. Whereas in case of the second mesh, so here we'll write 12, okay, because this is the voltage rise, as you see. Rest all are the fall. So against this 1 ohm, instead of just I1, so what are the at this super mesh, there is current through by I1 plus I2. So this would be current by I1 and I2. This is I1 plus I2, and across this plus 3 I2. So from these variables you can get the value of I2 also. So the value of I2 you can calculate easily with the second voltage source. So this is not a big problem over here. So basically we have to understand, if there is a current source between the two labeled nodes, so this is a super mesh problem. If there is no resistance connected to it, so you can easily calculate the value of I2, that is 2 amperes. Let's solve a slightly bigger problem to understand the super mesh in detail. So let's solve one more problem. So let here be, so this is again for super mesh I'm taking, I'll take plus, so the other side would be automatically 8 volts, okay. Then here I have 1.5 kilo ohms. Here another resistor, and I have this thing, I have this 3 kilo ohms. Very good. Now I have a current source over here, okay. This is a current source and its direction is here, it is 0.5 milliamps. Already I told you, volts and volts, it's in kilo ohms, and this is in milliamps. This is the standard convention. And put one resistor over here, okay. So this be 3 kilo ohm, okay, let this be 10 kilo ohms. On top of that, let's put one more resistor over here. So till here, okay, this is, let this be 2 kilo ohms. So first step would be to label this, okay. Let's label this. This is point A, so this is A till here A. Okay, let this be point B, okay. So B point is till here. So let this be point C. This is the reference, you can see C over here. So A, B, C, okay. Let this be over here, this be point D. So if we carefully notice 1, 2, and 3, we are understanding there are three nodes over here. So if we keep this as I1, okay, and the other thing as, see, in the other thing we have already current is given 0.5 milliamps, okay, and let there be one more current over here, this be I2. So if I have to take super mesh, so I have to take with respect to I1. So the my super mesh would be like this, okay. That would be my I1 plus I2. This would be the direction for the super mesh. Now let's apply. So applying KVL around the labeled mesh. Let's apply KVL. First step would be to apply KVL around labeled mesh. So labeled mesh. So mesh number one would be this. What is happening? Okay, no problem. Okay, no problem. So apply KVL around the labeled mesh. So this is the mesh number one over here. So this is our labeled mesh over here, plus minus. So this is our labeled mesh. So first loop is this. So you can see the I1 direction is like this. So this is voltage rise 8 volt, rest all there is fall there. So here 1.5, okay, 1.5 I1 plus 3 I1 minus I2, and I2 we know is 0.5, okay, minus 0.5 because I2 is 0.5. So here we can see over here, see there is this current is I1 over here, and now let's suppose we have to apply it to the super mesh. So in order to apply it to the super mesh, so super mesh is this blue marked. So here it was the first mesh, okay. So in the first mesh we straight away wrote 8.5, okay, into this was our closed path over here. So okay, this is my mesh path over here. So I took 8 volts, 1.5, multiplied it with the current over here, that is I1, okay, I1, and this was plus 3, so this was a circulating current over here, that was 3. Okay, now let's go for the super mesh. It would be 8 volt. Now you can see the super mesh over here, it is 2 into I2 because here I2 is getting flowed, okay, 2 into I2 plus you can write 10, because I'm taking this mesh, so here 10. So when I will write 10, so 10 has encountered this current plus this current, okay, so we have to write 10 into I2 plus zero point 0.5. So when we will be solving the super mesh problem, so we get the value of I1 as, and I2, I1 would be around 19 divided by 9 milliamperes, and I2 would be 0.25 milliamperes. So if you have any confusion why, you look at the previous problem also. Here see, first mesh directly I1 value was calculated, it is given like I2 value was 4 milliamperes. Then what we did is we wrote a super mesh equation wherein we took this variable and this variable. Now this variable had a direct link. See, this variable, the current that read was not I1 but I1 plus I2, wherein this is an independent variable, it was I2. Similarly, if you move to this part over here, see when I'm writing, so this was an independent variable, it has nothing to do with this 0.5 ampere, it was not interconnecting. Similarly, like if you look at back also, this variable was not independent, it had connection with, whereas this is independent. So wherever there is a variable that has linking with this, so you have to take this as a super mesh. So when you are taking the super mesh, instead of taking only I1, you have to add that current, just like the case of super node. Hope you have understand the problem. For getting content like this, please like, share and subscribe. Thank you very much. Thanks a lot.